in the same thing. Now the pressure is a little bit higher on one end than the other because it's not an exact alignment off the test rig here, but it's taken a while before we actually mark the product with the edge of the roll. And we're getting a little bit marking right at the splice tape area where the roll is bouncing up and down. And that took quite a few revolutions. So under a normal operational situation, you should not get any marking with this particular type of setup. And it's very light pressure. I mean, I barely put the roll down. We just want it to contact, and any type of elevation defect should register quite sufficiently on the roll. And what happens is the wrinkle gate basically will lift up, allow the light through. The photo detector will then initiate an alarm, and we'll process that signal, filter out any noise levels, and produce a elevation defect signal. SD Warren product for wrinkle and coating lump detection for the Embosser. We're going to run this up to speed. We have the wrinkle gate here. This device, when an elevation happens, will lift up. It pivots actually in an actual application. Right now I have it C-mounted. Very light pressure. We're determining whether or not the rolls will mark the product. Over time they will. We're operating this on a speed roll that's about a 6-inch diameter. We're going to rotate this up to about 450 feet per minute and estimate when we might have a mark. We're going to do a manual turn right now, which would indicate probably production speed and give us about 1 rotation. In an actual application, obviously the product is not underneath the wrinkle gate for a very long period of time, and multiple revolutions should indicate whether or not this particular roller would actually mark this coating, which we believe will not happen. So an initial roll where the product had a full rotation of the speed roll indicates no mark. We'll put this up to speed. The correct way. So we got about 10 or so revolutions there at a quick rate of speed, and there is no markings. We'll run this up even long. Now we're going very fast, and again we're not getting any markings by the roll, except roughly right where the splice is that we put in here, because we have a double rotation of the double thickness of the product due to length and whatnot. So as you can see, this particular application will not affect the product as it's run, and we should be able to do a successful job on any elevation defect. Again, what happens is there's a little pivot point here on an actual application. So this thing is basically just kind of hovering, and it's applied to a nice straight machined roll, and when an elevation happens, this device will basically go up and down like that, and will allow a certain amount of light through, which will be picked up by the sensing assembly. We'll go through some filtering techniques, reduce the noise levels, generate a signal, and indicate an output either to an alarm light, an alarm light, and an alarm, or we can go into a full data acquisition, which would be historical loading and whatnot through a computer program.